Hey kids, Mr. Jong here. Today I'm going to be going over congruent triangles. How are they connected to similar triangles? And at the end of the day, how do we prove things are congruent beyond just looking at them? Let's go ahead and get started. As a reminder, similar triangles, like the one over here on the left-hand side, are the same shape but maybe a different size. We may have it half a size smaller, we might have it 2 times bigger, but at the end of the day, they are still the same type of triangle with the same corresponding angles. Congruent triangles, on the other hand, like the one on the right, are exact copies. They are the exact same size, the exact same shape, and at the end of the day, all the measurements are going to be the same. But how can we determine that if we don't have all the information? What definitions can we use to differentiate similar triangles and congruent triangles? So remember, when we compare triangles, or any figure for that matter, we are always looking at two characteristics of the shape: the sides of the shape and the angles. And just like our triangles here, we're going to use the sides and the angles to differentiate whether the shape is similar or congruent. Let's go ahead and get started, shall we? Now, when we first compare shapes, we want to look at their angles. Angles help us determine if the shapes are exactly the same type. In a similar figure, you'll notice that the angles themselves are congruent, right? The corresponding ones for that matter. So this angle in this part corresponds to this angle in this shape, and they are exactly the same. Congruent figures, on the other hand, are exactly the same. So in a congruent shape, the angles that correspond to one another are going to be exactly the same as well. But if we continue on and we compare the sides of the triangles, you'll notice that, hey, this is where things start to get a little bit different. Similar triangles, the sides of them are just proportional to one another. And the difference is that the sides just have an equal ratio. So they may not be the exact same length, but all the sides will have the same multiplier. So for instance, from our original shape here to our similar shape, it's getting smaller. Now, by what scale factor? It could be a half or a third, but every side shrinks by the same amount. Whereas with congruent triangles, the corresponding sides are the same ratio, but that specific ratio is 1-to-1, meaning that every one length or one unit of this side matches up equally to the same unit on the other side. So a quick review: similar triangles will have corresponding angles that are congruent and corresponding sides that are proportional. Or another way of thinking about that is, if I make a fraction that compares the corresponding sides, that fraction will be the same for all the sides of that triangle. Whereas with congruent shapes, they too have congruent corresponding angles, but the corresponding sides must have a ratio of exactly 1. It can't be 1/2, it cannot be 2, but all the sides must have that same ratio of exactly 1. So what does that look like? How can we differentiate whether a shape is similar or congruent? Well, we have this method up here. If we want to prove shapes are similar or congruent, we want to use these two steps. Let's go ahead and zoom in on this example up here at the top. So to prove if shapes are congruent or not, we have step 1, prove that they are similar. If we could prove that the shapes are similar, then we will automatically know that all the sides are proportional and all the angles that are corresponding are congruent. So in this example here, I have the triangle on the left and the triangle on the right, and I can prove that they are similar using angle-angle similarity. This angle corresponds to this angle, and this angle corresponds to this angle. Both of them, by having the same markings, mean that they are the same angle or the same measurement, and therefore they are equal. We can use that to prove that we have angle-angle similarity. And now that we have proven that they have angle-angle similarity, we can move on to step 2, which says that we have to prove that the shapes have a pair of congruent sides with a ratio of 1/1. And we have that right here. This has a tick mark of 1, and this side has a tick mark of 1, both of which are the hypotenuses of these right triangles. And because they have the same length, right, as denoted by the tick marks, we know they have a ratio of 1/1. And therefore, because I have proven that they are similar, and I found at least one side that has a ratio of 1, I know that all sides have a ratio of 1, and therefore, these two triangles are, in fact, congruent. All right, so let's recap. So, to prove if a triangle is similar or congruent, we use very similar steps. We got to prove that, all right, we either have to see if our angles are congruent, but where we differ between similar and congruent triangles is that similar triangles, or shapes for that matter, must just need to have proportional sides, whereas congruent triangles have proportional sides, but that proportional ratio must be 1/1. I hope this helps you understand congruency a little bit more, and I'll see you guys next time. Take care.